Welcome back to this project on natural language processing for text classification. In the previous video, we built our training and testing data sets of nicely pre-processed text messages, and now we can start detecting and identifying whether or not these text messages are spam or not spam. And so to do that, we are going to be using classifiers from Sklearn, wrapping them in NLTK, and then deploying them in this notebook. So let's add a nice comment to start here. Let's see, my last number was 3, I believe. Let's do 4 point. We'll say scikit learn classifiers with NLTK. All right, so this is what we're doing now. We've gotten through the hardship of pre-processing the data, and now the fun can come. All right, so in the previous project, we looked at one simple example of wrapping a classifier in NLTK. No need to just limit this to one. Let's go ahead and jump right in and just build a list of classifiers and models and see which one's actually the best for our specific data set here. But the first thing we need to do is import all of these. So we're going to use a nearest neighbors method. So let's import kneighbors classifier. So that's our first one. From sklearn.tree, a decision tree, let's import the decision tree classifier. From the sklearn.ensemble methods, let's import the random forest classifier. From sklearn.linear models, or linear model, let's import the logistic regression model. Let's also import the SGD classifier. From sklearn.naive Bayes classifiers, we're going to import the multinomial, if I can spell it right here, multinomial naive Bayes classifier. From sklearn.support vector machines, we're importing the SVC, which is a support vector classifier. And then finally, last but not least, we're going to import from sklearn.metrics, the all-important metrics. We're going to import the classification. There we go. Report, accuracy score, and finally a confusion matrix, so we can analyze our results here. Always a good idea to understand your performance. This is a nice chunk of import statements. Let's go ahead and run this, make sure I spelled everything correct. And of course, I did not spell everything correct. We need an I here, classifier, not just classifier. We don't need that. All right, we're good to go this time. We got them all in there. All right, so now let's define the names of these models. So define models to train. These are just going to be the names. Oh, so we have a list here. First one first, nearest neighbors. There's that. We have a decision tree. We have a random forest. Logistic regression. A simple SGD classifier, which we'll talk more about in a second. Our naive Bayes method. And then finally, a support vector machine. Let's denote that it's a linear support vector machine is what we're going to be using today. So here's our names. That looks good. Now we actually have to initialize our classifiers. So we have a list of classifiers here. These are going to be just the instances that we imported above. So we have kneighbors classifier, comma, decision tree classifier. We have the random forest classifier. If you want to just Control Z and Control V, copy and paste these down from above, you're welcome to do that. Logistic regression. I don't think it's going to be faster than typing though. That's why I'm doing this. For the SGD classifier, we actually have to set a parameter here. We got to set the max iterations. We're going to just set those to a nice even 100. And then our last one, our support vector classifier, we have to set the kernel. We want a linear classifier here. So let's go ahead and set linear. You can use a couple different kernels with the support vector machines to achieve nonlinearity. We're just going to start with this since we have some other methods in there as well. All right. So we're good to go there. So we have our names, our classifiers. Let's pull these together. We'll zip them together in a dictionary of models. Zip names classifiers. So this will give us a nice dictionary of our models, names, and then the classifiers after that. So we're good to go there. Actually, let's look at this, make sure it runs. It does not. Name classifiers. I forgot an S up here. There we go, much better. Let's add a print models here. Alright, nice. This is actually a list. We can look at some of the parameters, the defaults that these are going to be using. For example, our number of neighbors in our k-nearest neighbors is going to be 5. So this is kind of the defaults that these are coming with. Decision tree. We have here random forest, logistic regression, the SGD classifier. This one has a lot of parameters. And actually, so one thing to note here, and this is going to be an interesting comparison between these. This is one of the reasons I want this here. A hinge loss with the stochastic gradient descent classifier is actually the same thing as a linear support vector machine. But it's going to be optimized slightly differently because it is using that stochastic gradient descent. So we're going to see some different results between these two. However, it is important to note that with a hinge loss, really what we do have here is a linear support vector classifier. So it'll be interesting to compare and contrast those a little bit. Here's our multinomial naive Bayes classifier. Alright, we can take this off. Alright, we're good to go there. Now we actually get to loop through these and wrap them in the Sklearn classifier. So one thing we have to do is we got to import that. We want to wrap models in NLTK. So to do that, we are going to say from nltk.classify.scikit-learn import the Sklearn classifier. All right, we're good to go there. And then if we come down here, we can say for name and model in models, let's build this NLTK model. So the NLTK model is going to be an Sklearn classifier instance of whatever model we might have. And then to train this, really simple, we'll simply type NLTK underscore model dot train, and we'll pass it our entire training list of training text messages that were generated in the previous video. So we don't have to split apart our class labels and the text message here. It's going to do it automatically because of the way this Sklearn classifier instance works. All right, so we have that. Let's get some scores here. So accuracy is going to be equal to the nltk.classify.accuracy. NLTK model, and then we'll pass it our testing data set, our validation data set. Let's go ahead and multiply this by 100 so we have a nice even percentage. And we can print that out. So we'll say brackets here so we can put the name, accuracy, dot format. We'll pass this the model name and then pass it the accuracy. Okay, so this is a simple for loop, looping through all of our models here. It's going to train each of them individually, starting with the k-neighbors, working down to the linear support vector classifier. It's going to test them on the testing data set multiply that by 100% to give us an accuracy percentage here, and then print that out for each one. So let's go ahead and start running this. And so we have up above, if we look, 4,179 text messages in our data set. Each of these have a feature set that we built that is 1,500 features long. So these take a little bit to go. So it's actually going, it already finished the k nearest neighbors, and we get an accuracy here of 92.75%. Not great. Don't worry, some of our other algorithms are going to beat the k nearest neighbors classifier. So it just kind of goes to show that clustering might not be the best approach here. So here these are starting to come. We have the decision tree accuracy much better, 94.83%. This is going to take a minute or two to run, so what I'm actually going to do is just pause this video. It's not going to take more than 4 minutes, but I don't want to just sit here narrating as these pop out. So I will catch back up with you in a second. You can let yours run as well. Alright, I'm back. All of mine have finished training. Hopefully yours did as well. We're getting between 94 and 95% accuracy here. So pretty good, better than we've had, but a spam detector that's only 95% accurate is still actually not going to be that great. So let's look at some of the ways that we can potentially improve this. They may or may not work for our data set. However, it will be nice to cover some of the other methods that you can actually use with NLTK and Sklearn. So what we're actually going to do is we are going to build an ensemble method. And what this is actually going to be is it's going to be a voting classifier. So this is going to be a hard voting classifier. So basically, in our ensemble method, we are going to combine all of these algorithms that we just trained. We are going to ask them to vote on whether or not they think that particular message should be classified as spam or not spam. And then since we have an odd number of classifiers here, we have 7, we are going to have a total vote of either spam or not spam between these. So each of these classifiers gets an individual vote. At the end of the day, whichever spam or not spam gets 4 or more votes, that is what that text message is going to be classified. So instead of relying on the strength of one individual method, we are going to combine all of these methods into a single classification algorithm. Alright, so to do that, we can go ahead and import the voting classifier from Sklearn. So from sklearn.ensemble, import the voting classifier. And actually what we can do now is just go up here and copy all of these, because we're going to be using the same models. One thing to try might be to remove the k nearest neighbors here, because it was our worst performance. Potentially the decision tree as well, since those ones were inaccurate. But for now, we are just going to leave them included, because perhaps they could give us some benefits still. So models, we are going to do a zip, names, classifiers. Alright, so we have that. I should have just copied that from above. And now we build our ensemble method. So we'll have NLTK ensemble. And we actually have to wrap this entire instance in the Sklearn classifier. So NLTK is going to treat this as one individual classifier. It's not going to see the underlying 7 algorithms that are going into this. We then call our voting classifier, not baiting, we want voting, our voting classifier instance, and we pass to it these estimators. So estimators is going to be equal to models. So we have the names and the classifier instance for each of these. We're going to say voting equals hard. So there's 2 potential methods here. This is actually the default, but I thought it was worth mentioning. A hard voting is simply a binary or a class label output from each individual classifier and then looking at which one got the most votes. If you did a soft voting here, actually what you'd get is each of these algorithms would output a class probability distribution, so their probability that each particular message is either spam or not spam. There would be a summation of all of those probabilities, and then like an argument max type soft max on top of that that would take those probabilities and convert it to a class label. It's a good idea to stay with the hard voting if these algorithms haven't been optimized. However, if these are optimized each individually, then you can go over to the soft voting methods. One of the things we can do with this is number of jobs. We're going to set equal to -1. This just means that it can train all of these in parallel. And this -1 is simply saying use the available cores that your computer has. You could set this to, for example, just a 2 and it would use 2 cores. But if you have 4 cores on your computer in your CPU, then it would be a good idea to utilize all of those. So that's what the -1 here is, just saying use all the available cores to train these in parallel. All right, so there's that. Now what we can do, treat this the same way we would the Sklearn classifier instance above. So ensemble NLTK ensemble dot train training. That's all we have to do is pass it the training data set. And then let's do the same thing above. Let's take this accuracy score and we're going to print that out. But we don't need NLTK model here. We need the ensemble. And then we don't need a name. We know the name. It's the ensemble method. So we'll have ensemble method accuracy. All right, so let's see if this improves our results a little bit. We'll go ahead and run this. Oh, and we actually have an error. Voting classifier is not defined. I have forgotten my I again. There we go. All right, much better this time. So training in parallel here, which is good. Hard voting method. All of these classifiers are being passed to this ensemble method. It's not going to take as long as this guy because this guy wasn't training these in parallel. So we'll see how this does. But it is going to have to think for a few seconds here. Because again, we still do have 4,500. And here we go. So our ensemble method actually achieves 95.55% accurate. So actually not that much better than just our individual classifiers above. And so what that actually is probably telling us is that we have a few text messages that are just really hard to classify. Like all of these algorithms above are missing approximately the same messages. So it's not that the naive Bayes classifier missed the first 10 and got the rest right, and the random forest got all the start ones right and the last 10 wrong. These are all probably missing some of those same text messages. So that's a little bit unfortunate. Our ensemble method didn't improve our results too substantially. However, this ensemble method still might be better at generalizing than our individual classifiers did above. It simply means we've got some issues with our data sets, such as a couple text messages being really hard to classify and all of our classifiers missing them collectively. But that's okay. Let's go ahead. Actually, this error is popping up as well. This has been identified in Sklearn. The next version of Sklearn is actually going to have a bug fix for this. It was discussed in Stack Overflow. It's nothing to worry about for us. Just up above here, if you have a newer version than 0.19.1, this should be fixed. But other than that, nothing to worry about. All right, let's make some class label predictions for the testing set. So we can look at this, we can see where we are going to wrong and where we are going right. So text features labels, let's unzip these. Text features labels, there we go, zip. And to unzip, we just use an asterisk here, so testing. And our testing had our messages and our labels, so we're just going to pull those apart. We'll say prediction equals NLTK. We use our ensemble method. Dot classify many. So this is what you have to call from this Sklearn classifier instance in NLTK to do predictions. We'll pass it the text features. So notice now we don't have those labels attached to this text features. Alright, if we go ahead and run this, we'll generate those predictions. This NLTK ensemble method was already trained up above right here, so we don't have to retrain it or anything like that. We get this error again, or I get this error again, you may not, but looks good. We should be trained. And now we can go into kind of our classification reports and our confusion matrix to kind of see what's going on here. So we're going to print a confusion matrix and a classification report. So we'll print classification report, which we already imported above, labels, and then prediction. Our confusion matrix, we're going to use a pandas data frame. So we're going to build a data frame here. In this, we're going to have a confusion matrix of our labels and our predictions. And let's label these a little bit. So we'll have index, double brackets here, actual, come over here, comma, we'll have ham, which was our anything that's not spam, and then we'll have spam, double brackets there. Come down here, we'll have columns, predicted, comma, ham, oh, got an accidental enter there, and then spam. Alright, so here's a confusion matrix. Let's go ahead and run these. And here we go. So here is our classification report. We've got precision, recall, F1 score, things that we have looked at previously in the past. So here, the 0 is our ham class. We're 96% accurate on that. We have very few false negatives, some false positives. On the spam class, though, actually, we denoted by this recall here, we can see we have a lot of false negatives. So we're not identifying all of the spam. We're letting some sneak through. Probably more harmful, though, is we have some false positives. So we're flagging some text messages as spam that shouldn't be tagged as spam. As a user, this would be really frustrating if your friend sends you a text message and 6 out of 100 times it gets tagged as spam and doesn't get sent. So not good enough to use in real life probably for this. But for this data set, not bad. Our confusion matrix here is showing the same thing. This is actually the total numbers. So for example, we predicted ham this number of times. 1,201 times that actually was ham. But 53 times when we predicted ham, it was actually spam. When we predicted spam, 9 times it was actually ham, 130 times it was correct, that was spam. So it's actually a good thing that we're letting through more false negatives than false positives. So here we're only flagging 9 versus 53. That's probably good. We want to let through some spam. We don't want to be taking messages out that are actually legitimate messages. That's more harmful to do. But either way, we got about 96% accurate, a combined F1 score, which is considering precision and recall, of 0.95 for our testing data set using this ensemble method. So not too bad. The important takeaways here are how to wrap these Sklearn classifiers using NLTK. You can use other methods that Sklearn can deploy, such as a voting classifier and ensemble method. You could do a grid search wrapping in this Sklearn classifier. It's very cool how you can integrate these two libraries and use these machine learning classifiers in these natural language processing tasks. So that brings us to the end of the project. We built on the foundation that we had developed earlier. We covered pre-processing the data. We looked into regular expressions, some much more complicated regular expressions than we have looked at in the past, in fact, as well. We did a little bit of stop words and stemming, which was covered in the first project as well. Word tokenizing, so using all of those fundamentals in this classification project. And then we did some feature engineering. We built some feature sets based off the most common words here. Note for you guys, a quick way to drastically improve your results here is to just get rid of this and use all of the words as features. So it turns out we're losing some useful information by restricting this to the most common here. But then again, it is going to take longer to train. For example, if you double this, not quite double in the time to training, but nearly double the time to train each of these classifiers. That's why we kept that kind of low. Here's how you import and use the Sklearn classifiers incorporated with NLTK to predict whether or not each of these text messages is a valid message or spam. So thank you very much for listening. I hope you learned a lot about natural language processing and how it is used in combination with Sklearn classifiers for tasks such as text classification. Thank you very much.